This is your first signature test of the year. It's called Composition of Functions. The first 6 signature tests are all a review of pre-calculus material. So obviously we have not started calculus yet, so these ones you should be able to do without any knowledge of calculus. So we are given 3 things. We are given a table. So this is the graph of the function, or I'm sorry, no, this is the table of the function f. G is this graph right here, and h is this function. And so we are going to use the table, the graph, and the function in order to find these values that are listed over here. So hopefully you recognize some of these notations. However, I will explain them to you if you do not. This first one, this function, or I'm sorry, this notation implies that you are adding together the function f and g and evaluating it at the value 2. So we're going to look at what f is at 2, and we're going to look at what g is at 2, and we're going to add those together. So f of 2 is 1, so let me highlight that. F of 2 is 1. G of 2, if we look over at x equals 2, we can notice that g of 2, notice that there's an open circle right here. That means that it doesn't actually equal this value. It equals wherever there's a closed circle. So we come up here to the closed circle, and notice that right here is the actual value of g at 2. So that's 4. So let me highlight that as well. So at 2, the correct value would be 4. So f of 2 is equal to 1. G of 2 is equal to 4. So therefore, 1 plus 4 is equal to 5. So let's write that right here. For the next one we need to find the inverse. So we're looking for h inverse of 1/2. All right, so the inverse of h, hopefully you remember how to take the inverse of a function, but you start by switching the x and y. So we'll start with x here equals -1 over y minus 2. We can multiply the y minus 2 over to this side and then divide by x. So I'm just going to switch these ones places. So this is y minus 2 equals -1 over x. And then last but not least, we can add 2 to the other side. So we get y equals -1 over x plus 2. So this is the inverse function of h. This is h inverse. And we're going to evaluate it at 1/2. So if I want to go ahead and evaluate it at 1/2, I just plug 1/2 in for x. So that would be -1 over 1/2 plus 2. When you're dividing a fraction by a fraction, you multiply by the reciprocal. So that would be, instead of 1 divided by 1/2, it would be 1 times -1 times 2 over 1. So we're going to multiply by the reciprocal instead of dividing by the fraction, plus 2. So doing my order of operations, I get -1 times 2, that's -2, and -2 plus 2 is 0. So this is going to be 0. So right here, the answer is 0 for that one. All right, part C. Part C, f of g of -1. So this is a composition of functions. So we go from the inside to the outside. So we have the x value of -1, and the first thing we're going to do is evaluate g at that value. So for g, I'm going to figure out what the value is at -1. So let's erase what I already did on the graph. All right, beautiful. And then over here at -1, if I look on g, notice that right here, if I go up, the function is actually equal to 2. So g of -1 is equal to 2. So the inside part right here is equal to 2. So I'm just going to rewrite this as f of 2. And if we're going to simplify that, f of 2, if I come over here, we already figured out is 1. So f of 2 equals 1, so this is 1. H of f inverse of 1. I like this question because you have to understand how inverses work in tables, not only how to find the inverse algebraically, but how it works in a table. So here we have f inverse of 1. All right, so f inverse of 1 means that you have to go over to f, and f inverse, if you know the properties of inverses of tables, we're not looking over here for a value of 1 because that would just be f of 1. But if we're looking for the inverse, I want to know where does the answer equal 1, because the inverses, the tables are switched because x and y coordinates on original functions and inverses are switched. So if I look over here for 1, I see that f inverse of 1 actually equals 2. So inside of these parentheses here, f inverse of 1 is equal to 2. So I'm going to rewrite this as h of 2 equals, and then if I plug in 2 to this function, I get negative 1 over 2 minus 2, which is negative 1 over 0, and you're not allowed to divide by 0, so this is actually undefined. And then last but not least, this is an interesting one as well. So this is saying that f of g of x equals 1. So when I plug in some x value into g, it equals something. When I plug in that value into f, it equals 1. And I want to go backwards and figure out what x was that I plugged in originally. So I want to know, what did I plug into f in order for that function to be 1? So again, I look over here, and I see, and I realized, oh, when I have f equal to 1, that means that I must have plugged in 2. So that means that g of x must equal 2. G of x must equal 2. Alright, so if g of x equals 2, what x value did I plug into g in order to make it equal 2? So if I come over here, and I'll highlight it for us so we can see that. If I look at the graph everywhere that the graph equals 2, you'll notice that there's actually 3 points that look like they cross it. 1, 2, and 3. It looks like the function crosses that 3 times. You'll notice here, and I actually colored over it so you won't be able to really tell, so let me kind of erase that. But at this point right here, notice that's actually a hole in the graph. So that's actually not on the graph, so it does not equal 2 at this point. So these are the only 2 points I care about. So there's actually 2 x values that would make this true. The first x value is at negative 1, and the second x value is at negative 3. So there's 2 answers to this one. The answers are x equals negative 1 and x equals negative 3. X equals negative 1, x equals negative 3. So that would be the 2 answers to this. And you can go back and check forwards. So if I plug in negative 1 or negative 3 into g, negative 1 or negative 3 into g, I get 2. And then if I look at 2 over here, that equals 1. So therefore, it is a true equation. All right, so that's how you can do the composition of function signature test that you have in class.